Okay, good morning, everybody, from my side as well. I hope that folks online could also hear me and see the presentation, and also that in presentation mode. Yeah. Currently, it is the case. So, thanks for the introduction. And as I'm here in the engineering department and also the faculty, just to make sure I'm not a pure or hard engineer. I am chemist from my education, and then went to management and was plant manager and R&D head a couple of years before joining academia. So I will talk today more about the managerial aspects and how really to foster with that the digital transformation. Of course, this goes a little bit into technical topics, but mainly the focus will be on the managerial part. But let's start first. Somewhere else. Let's start first with kind of engineering task you may know, and that is quite famous for the area Esslingen is placed. That is the area of Stuttgart, Baden-Württemberg in Germany, where we have the largest automotive industry with Daimler, but also Porsche. And here you see a brand new factory for the Porsche fully electric driven Taycan. And those of you who have maybe already seen automotive factory and assembly line, this is a little bit different. That's a really new factory, and that is based on the ideas of having a kind of smart, lean, green production. That means that we have in this factory a completely flexible networked production with Industry 4.0 technology. That means that they could produce a single car independent from which order came in. So unit piece one. Of course, it is a high-end, high-priced product, though that is feasible in that way. But nevertheless, we will later see that this could be applicable for more, let's say, standard products as well. Lean, okay, of course, here they are trying to have only a few handling steps, and the car or the chassis rests on that equipment over a long time. So you do not have this kind of moving assembly line as you know it from ordinary production. And green, yeah, the factory is based to be CO2 neutral, so that should be match, of course, the fully electric car. So that's a little bit the idea of this. Now the question is, of course, how to come to those areas. And before doing this, Industry 4.0 is the word used mainly in Germany, Europe. But if you talk about digital transformation, you may hear smart factory. All those words are sometimes used in different contexts. So you really have to know what you are talking about. And I just want to have 4 phrases or 4 definitions here. We always have to talk about cyber physical systems that includes some digitalization and networking. On the other side, talking about Internet of Things, this goes more in the direction of the product. We will see this later. Less within the company, of course, you can use this, but then you talk normally about a smart manufacturing, a fully connected, digitalized manufacturing, and then Industry 4.0, as I take it, the overall explanation for all these elements. So just to be sure what we are talking about. Okay, I'm not going into detail. I think all of you may know we have this, I do not see, at least for the first and second, and later for the third and fourth industrial revolution, really the revolutionary thing, but it is a kind of evolution. What we will see is that, in my opinion, we have a real revolution from the third to the fourth, or even beyond, when we talk about how to manage them. The technical situation was an evolution. So you started with water and steam power, helping human beings to use physical or to handle loads. Then we have the mass production that was just combining all these machinery. The next step was trying to automate these machineries. And now the automation that was already there when we talk about the Industry 3.0, that a lot of people forget. Automation is not Industry 4.0. Industry 4.0 is that we talk about digital processes, and that we talk about connectivity, and that we talk about a huge amount of data that is available across all aspects of the production. People call it big data, but to have a lot of data you can use and simulate things. But you see, technically it is an evolution. We'll see how that has a revolutionary effect on management. Okay, if we go to the manufacturing, then I would take another idea. This is also here a kind of vision 2015 by Mercedes-Benz that shows that you will have this interaction between human beings and robots. This will also be a next step one has to think about, that talking about robots, however you like to tell that you have to interact. But we can also have the kind of timeline in a different aspect, because it's not the question of the technology, it is the question of what we do with the technology and why we use it. And in the early beginnings, we have a situation that we had manual production. Product variance, one element. On the other side, if we go further, then we have this machine-supported manual production, still one unit. Next step was this mass production. Now, the single piece didn't play a role. Also, quality has to be on a different aspect. Just a moment. Trying to. No, I couldn't do that here. No, trying to get rid of the bar. Okay, and then something specifically happened, and that is that we started to have our automated production. And from that moment, we have three different paths. One, we all know, is globalization, but together with regionalization. Why that? Because the smartphone, of course, that is a global item. But if I come to Sri Lanka, I have to take a kind of connector to plug in. So that are regional products we have. But the main part today is that we could go back to a customized product, unit piece one, more or less with the same possibilities we had with the okay, thank you. You have unit piece one with the technical possibilities and in many cases the costs by mass production. Think about 3D printing. This is one option. So we have come back to the single unique piece, but with completely different way of doing this now. If we think about that in a more enhanced way, we have to think about the digital transformation. And now, sometimes we forget that digitalization is really not all a company has to do. It is a process within that you try to use all options, data, equipment, sensors, to have a kind of innovation and to give improved products. And another point to be mentioned is a lot of consultants, at least in Europe, say, oh, you should go digital means you should go to be a platform provider, but not all companies could be Amazon's, Alibaba's, or similars who should produce the products they are shipping. Apparently, that is also something we have to accept. I've seen so many people that say, okay, now you have to go to be a kind of platform provider, no assets, nothing. Who's going to bake our bread? So these are the companies, and that are also the, let's say, focus for engineers and for digital aspects of engineering and not the Amazon. So if we think about that, we have to go back and think what is that is necessary in a company, and that is we have that customization. At least in the West, people are now more interested in having customized products than, let's say, standard products. Sometimes even you can have less advanced customized products are more interesting than the high-end standard products. So that is a tendency. And also the moment someone is offering a customized product in your market segment, you have an issue. So that is what we have to do. If we want to go into that, we need that digital transformation, because otherwise we have to do that manual, and at least in Germany, that will be not affordable. So you have to go and think about a digital company. Customization, just an idea here, a sneaker. And for that, for example, you can use parts of 3D printing, you can use a design manufacturing. Not talking about the question of shipment, and if you have to back short production in some areas just for having not a too long lead time, but you need the digital transformation, and that means we are talking about the factory, and on the other side we are talking about the product. And that's where I said smart factory, applying more to the kind of production, smart product, more in the way of the product itself, and that is IoT. I could have the game and play it with the sneaker. Some of us use a kind of tracking for the steps they do every day. You could integrate that in a sneaker if you like, but more enhanced for autonomous driving, so autonomous cars. But smart housing is the same, or smart usage of electricity is, for me, more important than having the sneaker with the sensor. But okay, nevertheless, this is the product, but they are related with the factory and later also with the part of after sales and the maintenance. So that is where we have to think about what to do. If we go back a little bit to the idea of Europe, And the question, why do companies really go into that digitalization? Then we find, of course, cost reduction benefits mainly are playing a role in all areas. Supply chain management, you could imagine the question of utilization. You can easier go also to a kind of just-in-time delivery. The factory I presented to you, the Porsche factory, is based within Stuttgart city, which means, could you imagine the difficulties to transport items into that factory? They nevertheless want to be just in time to reduce their premises in the storage. And don't forget, in car production, about 70% are bought in materials and equipment. So this is really a hard work to do. And there you could optimize a lot. Asset management, of course, this also unplanned downtime. I'm not going into details of the production planning, but you could, of course, reduce if you connect all your production steps just to, first of all, simulate, check your process flow, see all your different takt time parts, and then going further and optimize this. So in many cases, then they reduce from 3 shifts to 2 shifts with the same output. And operating efficiency, I'm not going into the details, but inventory carrying, of course, related to both of them. So that is the things you have to think. So I'm skipping that. Now, if we go to the idea of transforming a company, we did a lot of research part and thinking how you can do this and check it with companies here, especially SMEs. You have a logical path, and that is, of course, you have to analyze your present situation, because there's a good reason why you are in the market. So apparently you should not have to completely destroy your background, but you have to know where are your gaps, where are your problems. Then the next thing is, and that is nothing technological, but in the end you have to do it. You have to check the market trends and your options. And sometimes you have to say, sorry, this is not my option. You have also to be very honest to you where to go. So this is the kind of analysis you are going to do. The next step is you have to create and map it out and communicate to all of your employees. And I would go even one step further and say to communicate to all your partners in your value net, not value chain, we have a value net today, your strategy. Because if you do not have a clear strategy, what should I later implement? Which machines, which software should I buy if I do not exactly know where I want to go? So this is important. Unfortunately, especially in SMEs, that is really having a big impact, but it is not done thoroughly. Of course, you have also to think about your capabilities and your resources you need. And coming back to Germany, we also have to face sometimes the situation, I do not have these resources. For example, we are honestly, especially in the SMEs, lacking some very good IT and engineering people, and they are not on the market. So they are more or less hired by the big companies, and there is a trend in Germany that not so many people going into STEM and engineering programs at the moment. So by the way, a good chance for others. Then you have to connect your parts of your company. If I talk about that, it is not connecting digitally. It is connecting with your brain and to think what you really have to connect and how. And the last step then is really to implement the IoT and Industry 4.0 solutions necessary for your company. And of course, you have also to be aware that they have to be flexible, because even though doing a strategy, you could not be sure that this strategy will not be made obsolete by one new market entry with a completely different idea, but focusing better on your customers. And you have to change it. So your strategy and also your implementation of equipment has to be extremely flexible. Otherwise, you're like a dinosaur with a meteor coming down, and then you have to have a problem, and you know the small mammals survive. So that is a little bit the situation you may face. Another point, issues. I think you all know VUCA, so volatility, uncertainty, complexity, ambiguity, adding speed and assets to count. So now you could say, dear God, what should we do? But positive thinking persons, and I hope I am one of those, you could go and say, I transform this for me and for my ideas into, I need a vision, I need a thorough understanding of my position, I need a clarity in telling everybody what I'm going to do, and I'm agile. That was what I derived from the last 6 steps. Again, plus ambition, and speed remains, you have to be fast. Now, I'm not going into the details of the huge amount of choices you have when it comes to digitalization, connecting more and more systems, devices, sensors, assets with people throughout the networking, ranging from wireless ideas, low power, wide area networks, whatever you can think. But the most important is we are talking about a lot of mobile solutions and cloud solutions, because with that you decouple the production from the people steering that production. We all know that teaching could be done online. You could also have a lot of remote access to machinery. If it is well done, and if you have the adapted robots, you could for sure, even in your lab, have your machines being controlled back from home or your office, but you need a good mobile system and you need a good kind of cloud and Wi-Fi. So, but going to that, we are out of the area of core competences. Think about the automotive industry again. The German automotive industry, OEMs, were so proud that they are the best in designing and constructing and manufacturing combustion engines. Combustion engines will not be the future. So I have a fully electric car of my own and I love it. So, but what is necessary is that you have these kind of dynamic capabilities. And by the way, that is nothing new. It was done in the late 90s, this concept, but still a kind of unveiled book for many SMEs, because it has a different approach. And I think this approach is especially also necessary to think about when you are an engineer, because this goes in a different way than the engineering education is, and in many aspects has to be. That is based on math, based on physics, and based on logic. But if you think about, you are enablers as engineers for creating products, and products are just enabler for creating a better or different life we do. So you have to also have this kind of sensing capacity that you recognize opportunities, customer demands. It is not the salespeople, it is you that have to compare customer demands with technical and engineering feasibilities. Technology options go in that direction. Then integrating capacity, that means combine different activities, engineering activities, combine different even companies to produce maybe a product. This goes into the coordinating capacity. And this is now going beyond a single company. So as engineers, you know that you work together with other engineers, but this will become, in my opinion, a big part in the future, that you collaborate with your colleagues from other companies, maybe even from competitors, to work on specific goals. Of course, then you have the question of IP and all this, but it will go in that direction. And learning capacity goes along with that, because if you collaborate, then you have to learn and adapt your knowledge, and also be open to include external knowledge and also give knowledge to others. We do this in academia across universities, but it will come also for industries, because even a big OEM will not be capable to do everything in a field on its own. Well, financial wise, we could do it, but it will be illogic and is a waste of money. And I think they are aware of that. I allowed myself, or with the research work we did, to add two other dynamic capabilities. One is reconfigurating. That means we have now to accept, or not to accept, we have the wish to adapt each time to new situations. Only those will survive, that is classical Darwin, that are adapted, the fittest for adapting the possibilities, and to learn from best practices. And the last one, and that's where I focus on, is that you talk about systems thinking. So I think you know systems engineering. This goes a little bit in the same direction, but more on a, let's say, managerial level. That is, that you have the whole picture, choose decisive elements, and then model interactions. So what does this mean in a way? Talking about obstacles, we have seen quite a few now. In that, we have customer-related barriers. We still have technical hurdles in many cases. Think about the situation that you have a power blackout. Immediately, you could forget your digital devices, except you have maybe a kind of generator backup. Organizational transformation. People are used to work in their old-fashioned way. Not just the worker, more the management. It's so easy, but now we have this collaborative management as well. It's different. Human resources, IT, and of course, don't forget there are financial limitations. If we go beyond maybe Daimler, Amazon, or how is it called now, the mother company, Facebook, that's the name. Okay, so, but we have those enablers. Engineers, IT guys created them. Cyber-physical systems, Internet of Things, mobile solutions, cloud computing, this advanced manufacturing, 3D printing as one, and big data and business analytics. So we all have this. We can derive from all of this 6 decisive elements. That means focus area. The first is customer satisfaction. If our customer is not satisfied, for sure he will not be our customer. If we have no customers, we are dead as a company. Quite simple. So for that, we have to give a specific product value. In the middle, our digital strategy again, organizational agility. We have our processes digitalized and the part of connectivity, connecting information across the network. So if I go to these 6 decisive elements, then what we can do is we compare that with challenges we are facing in doing this transition. And this is the awareness of what it can be, what I can have. So, and especially a lot of companies are still not aware about the real positive impacts of Industry 4.0. Either they have no clue at all, or on the other way, they say, oh, I have to do and I have to be online and whatever. So what is it really? Then you have your people. That means you have to train those people. It does not help if you have a good idea, if you are capable to use this, but your colleague is not using this. You may be ill for 3 or 4 days. Who's going to do that? Simple as it is. Collaboration. Okay, cybersecurity, I skipped that. You all know cybersecurity is a big issue, but has to be recognized. Talking about investments, problem, and IT standardization. This is one thing we face, especially in Germany, in companies. And when I was still in industry and plant manager in France, I think we had 5 or 6 different systems incompatible in our factory. So harmonize this. So we are not talking about the simple harmonization of, may I just having some different connectors. If you have an iPhone or Android, or you're talking about USB-C or USB-B and micro and mini and whatever. No, talking about the algorithms and the programs that are not connected. Yeah. Coming to more or less a kind of summary from that, we derived 18 fields of action. So there are 3 per those challenges where you have to work on if you really want to go into a kind of real transformation. These action fields have intercorrelations. And now we start talking about system thinking. You could not optimize one. As engineers, you all know this. If I'm trying to optimize one thing, then I may have a problem on the other side. That's like speed and fuel consumption with the car. If you want high speed and low fuel consumption, you have some difficulties and challenges. So that's where we, with a lot of surveys, came to, and you see there is quite a lot of interaction, some positive, that's okay, but a lot are really counterproductive. And now what are we going to do out of this? We created a kind of, and that was with students, with some master theses, a kind of system thinking model, connecting all these different elements on a logic basis to be able to simulate if you have an effect, an event on one of that, how does it influence the other? On the other side, if you do some actions, how they could change the system. that is not a crystal ball and predicting the future, but it gives a better view of understanding the actions, reactions in the network. And with that, you could at least do a kind of sensitivity analysis and playing, saying, what is happening if that may pop up? What is happening when this pops up and I do some specific action, or I have already done some preventive measurement, so that you simulate this at least to minimize the risk in your managerial decisions. So that is a little bit that what I, from the managerial point of view, understand also on fostering the digital transformation to make also sure it could work. And now going back to where I started, that is here, that is Arena 2036. That is a kind of complete idea of changeover of the production at Mercedes-Benz. It is as a kind of active research environment for the next generation of producing automobiles. And what is meant by that, just to give an idea, it is not because it is nice and fancy and bright. The idea here is Mercedes-Benz sees itself no longer as a car manufacturer, but an enabler to organize car manufacturing. So if you see this, you see the robots, you see the collaboration, but on each individual step, there will be different suppliers putting their parts into the car or connecting with the car, and it is no longer the responsibility of Mercedes. They are really, now you could say, a physical platform provider. If you see Amazon as a kind of cloud, they have the storage areas obvious, but here as a physical platform provider for all the partners, completely changed in mindset. Of course, you need all the technical equipment for that. But they, and why did they say 2036? They have the goal even to be earlier with that. That is obvious because this is 150 years after the first automobile was created by Daimler-Benz. That's the idea. So to summarize, top trends of impact: becoming digital to meet customer and citizen needs. And that's for the engineer. It's not to have a better equipment. It is not to have a smarter tool. This is the enabler for meet customer and citizen needs. So we can talk about sustainability a lot on that. I'm convinced that sustainability only will work with digitalization. Business priority by importance: improve the customer experience. Why? Because products are comparable. We have our smartphones and we just check who is offering us the best price or the best thing. So we need customer experience, either by the product or by the environment, by whatever. And top IT priority is not copy page. Yeah, of course, copy page for providing with the slide, but it is meant to be the same. It is digital to meet customer citizen needs. The top IT priority, especially in Germany, is now not making the factory digital, but making your access to the customer digital and give the customer all options, even to go within your production. In business to business, it is already done that it is not the production planning, it is the customer who is more or less triggering your production. Okay, so and this is now going one step further. Yeah, especially in Japan, but also in Europe, we have started talking about a kind of fifth industrial revolution coming okay, now you could say SIEGFRIED ZÜRN said the others are evolution, and now he's talking about a fifth. No, that's not me, but from the idea, what it is mainly based on cooperation between man and machine, and companies and companies and companies and universities and governments and people. So that is, we were talking a little much more about this kind of co-working in each area across the globe, as long as political situations let us do this. So that means we are, and that is for me, really the big game changer. And this is a revolution because now we have two situations. We have to cooperate across our former enemies, competitors. And the second is, and this makes it different to the former industrial revolutions, in the first, second, and third, pause a little bit, revolution, we had the situation that tools, equipment designed by engineers took away physical work from human beings. We replaced that always by more brain work, more other activities, creativity, brain-related activities. That's why the risks people saw even in the first industrial revolution, that all people will be unemployed, was not the case. They were shifting. Today, we are starting, I would say not for all, but for a lot of brain-driven activities, computers, artificial intelligence, that could do this. And in many aspects could do it better than we can do it. Just one example, we are talking about, or we are all talking about autonomous driving. Two extremes. We could implement autonomous driving right now, today, no problem. The only issue is we have to get rid immediately of all human drivers. The technique is there, you can do it immediately, but just have a look out there, all the three-wheelers, and by the way, crazy drivers like me and you maybe, and even though like to drive, we are the limiting factor. So on the other side, back to that, as long as, and we could not abolish all our cars right now, I do honestly not see at the moment how autonomous driving should work on a large scale for trucks and specific lanes and long distance. I could imagine, but all the urban areas with all these nice simulations they have, I couldn't imagine, because we are still there. And it's not, the computer is, as long as correctly programmed and online and not off the grid, logic. But we are illogic. Just making a U-turn for whatever reason, stopping immediately because I forgot to buy a bottle of water. So all these crazy things, we are the trend. But it will go more and more in that direction, that we have to find ways in collaborating. And that is an engineering question, because the logic and smart robots have to learn to interact with these silly human beings, not the other way around. We engaged robots formerly, not because the robots have been dangerous. It was dangerous that we, with our mind somewhere else, go into that direction. It's in mind. So, but this will be the next step. and maybe there are others, I do not know. Yeah, and to finish, we have to thank and shake hands with our friends, the robots, maybe not in this way, but in a other way, and work together. So that was, I hope, more or less in time. The presentation. One last comment on that. For this modeling here. Here we have done just recently a master's thesis with a student on modeling specific elements for a Sri Lankan SME, how it goes into the digital transformation. So I really do not know what is the time now.
5 minutes.
5 minutes, so I could show you this, just that you get an idea what we do and what we do also with the Sri Lankan company. Check which one. Oops. Come on. So that is one-to-one out of the presentation of the master's thesis done recently. The idea here was, as I said, to go into a system thinking approach and modeling. What does it mean to change SME here in Sri Lanka? So system thinking, I'm not going into details here, is a holistic approach. What Rohini did was that going into different modeling steps. So you have, of course, to find the right goal. What we are looking into? Then these elements. I talked about elements before. Assessing the element states because you are not coming from nowhere. Existing company. Developing all these networks and interrelations. That was the hard work, and having a lot of discussion with people within the company and other experts. Then trying to find the direct relations. Why? Because the system works from the idea that you just model the direct relations. Everything that goes via the elements is already part of this circle. And then you think about incidents, you think about actions, and hopefully you can then better make decisions. Just to go there in the end. And that's why I had some focus here. One major part was the organizational culture. Another was the worker enablement in this area. So talking about employee satisfaction, employee retention, experiences and skills. Talking here about digital knowledge and skills. So, and you see there have to be also some indicators to be found for the modeling later. Digital leadership was another one. So causing the question of degree of digitalization, digital acceleration index you can use to compare yourself with others, and time to market on digital apps. For example, in this case, Then we had the organizational learning, or the rate of effective technology utilization as an indicator, or transformation management, for example, number of changes introduced to meet customer requirements in relation to all those. Yeah, I think that's around the globe, talking about data privacy, privacy impact assessment, completion rate, data storage and connectivity, problem solving, rate of potential risk of data leakage, things like that. Of course, we have not to forget, without revenues, we will nothing doing in the future, and this enhanced development. So that was also a kind here rate of women and youth empowerment by the organization, so going beyond the classical, let's say, economic parts. And this was modeled, same idea here. You see this in this kind of interdependency network, done with a lot of feedback from people, yeah, being either in that field or from the company. So Chaminda here could tell more about that, as it was Blanca. Altogether, we had then 44 direct interrelations and creating an influence matrix, and that is a dynamic matrix. So when you do something, and that is in a kind not linear, means that you change also the in and out value of those kind of input and output per element. And then you could really see at a specific moment, where is the focus you should put on, because with the active elements at that very moment, you can change something. If I put money on that buffering or passive element, that is like spending money for, yeah, having a nice item, replacing a nice item. So it makes no sense. So the active ones that are that where you could have impact on others, mainly the critical ones, for example, that here is our technology, here transformation management. This is where you can, of course, act, but this is also an element where a lot of other elements act upon. So that is very critical in the way that you can steer with it, but it could also be altered by others. So you have to be very, very careful doing this. So that is what was done. Yeah. And with that, she created some scenarios with different, yeah, ideas what could happen, and then trying to find probabilities, risk management probabilities, to give an idea which could be the best actions with the uncertainty of the future. Of course, it's just a best guess. It is an intelligent guessing, not more, but at least better than just having your, yeah, gut feeling. So that was a project that recently, last Monday, was finished with that presentation by the student. Okay, thank you.
You will not now and have conversation.
Chat. So yeah, maybe it was not audible questions from the audience here, or of course the best way for those participating online, maybe via the chat, or you unmute your mic.
So in that case, how you are going to, who will be the responsible party? Something fails in the automobile being manufactured from this kind of.
It depends a little bit on the collaboration and project we have, but normally, as we are acting as the kind of enablers, the responsibility and the responsible project managers are from the companies. But really, it depends on the contract we have. Of course, we have also some research activities with companies, but then it is not a question of the end customer and liability and things like that, but then it's just within the project. But if at the end it is something the company is using for their own purposes, it is absolutely clear that they have to take the responsibility, except that is like in court, if we did something intendedly or we did it by craziness, let's talk it like this, then of course we are liable, but not if it happens and it was not predictable. But liability, especially in cyber-physical systems, is quite a big issue, and it will be even more critical when you have more and more parties. It's not necessary to have the university in that, but if we talk about a couple of different companies that work on one project and something happens, not talking about casualties that could be, then the liability issue is hard, but they are then contract-based, specified, and normally also insurances on that. But I do really not want to sign these contracts that may have millions of bytes. Could you raise your voice?
Yes.
Okay, thank you.
You spoke about a lot of the difficulties in implementing the smart factory or something like that. So, like in specific, let's say, let's talk about the technical hurdles that you spoke about. How do you overcome that when implementing it?
Okay. By the way, of course, you have technical difficulties that are different difficulties you may have. One of the big difficulties we have, technical-wise, are existing equipment that is not really capable to be integrated. Yeah, so in that way, you have two options. Either you could enhance them with a lot of sensors, or to be honest, kick them out and replace them. This could be, at that moment, going from a technical to a financial hurdle. Okay, so that is one thing. But first of all, the idea is it feasible to enhance this equipment? Or in other words, is it possible to create your smart factory without integrating this equipment, but please with the option when you are going to replace it, not to redo your process logic again. This could be, which means you have media breaks before a specific equipment and after that, but all is set that you could connect it on another point. That is in this way. But of course, we also have quite easy technical problems. You won't believe that in Sri Lanka, we still have in Germany areas where we have a very, very bad internet connection. Don't forget, we have our heritage of line phones. So I've seen African countries much better in internet connection in remote areas than Germany. So then, of course, you have another issue. You have even go and think, how do I set up my own, maybe for the factory network that works? Again, for a small company, immediately a financial hurdle. So you have to find other partners to establish, for example, a kind of industrial area specific network, also a technical part. So classical managerial answer, it depends. But you see, you have to think about that. But that's where you have to start, and you have to plan the full process, because when you start implementing here a bit, there a bit, you will never ever reach a final goal. So that's my idea. As I said, make the layout, then you see there are gaps that you could today not implement. But in your roadmap, you have to plan that this is implemented. And then you put this as a single element at that point without in and outs, black box. And the moment you change, you can do it. Okay? Answering your question? Okay.
We talk about important optimization, planning smart factory.
Okay, there are, of course, different ways of simulation. So, simulation for a smart factory normally is also that you try to have a digital twin of the complete factory and simulate all interactions. Of course, you could say this is also feasible for a traditional factory, if you like, but then it is in a way a standalone. In a smart factory, you have the situation that you could really in real time simulate the activities. A classical factory where you have this standalone machines, you could simulate that, but you have not that connection to the real working of that. So that is a difference you have in this kind of simulation. The simulations I've shown are completely different simulations. There are also simulations, but that are managerial simulations. And here I agree, you can do it for both. The only thing is that we apply it now more or less for the kind of smart factories. Why? Because we are in that field of research, and we are not in the field of the, let's say, the classical ordinary manufacturing or manual manufacturing. Managerial wise, you could of course make a simulation on that as well. But digital twins, I think, live for the future from the possibility to even interact with the real factory and not just being an off the line kind of playground. No, that was the one on chat.
One more question. So yeah, you talked about a little bit about the industry 5.0 that's kind of developing and it's more like co-working. But then at this point, we are still kind of still developing the industry 4.0. So don't you think that we are already co-working with the system already? So you said like, you know, I feel like it's just my thing that I feel like we are already working with it. So
okay, I just showed this and that are now ideas. Honestly, at the beginning I said I see things as an evolution, and with that things go parallel. In some aspects, we are, of course, already co-working. And maybe especially the pandemic has given us quite a push. But the co-working I'm focusing on, not I am, where especially Japanese colleagues are focusing on saying it is a new, let's say, step, is the co-working together with robots and artificial intelligence. To use really artificial intelligence in areas where we today are predominantly working, but trying to use our creativity with the logic of systems. And this in a, let's say, kind of standard way. Today we are doing this in some spots. But I fully agree with you, in a way, we are not here, and it's not 4.0 or 5.0. We have 4.18675 and so on. So you could take, if you like, the F1 mug bag at home, asking what is your password, the last 4 digits of the number P. So just to like this, so you could go to infinity with that specification, and yeah. But we are in a next area, and this is significant, and I think that is really the major game changer. We do not, or at least I do not see any other kind of, let's say, hideaway we have than our brain work, maybe together with our emotions. And now artificial intelligence is touching that in some areas. Before, we had a kind of hideaway where we could find our nice little bubble again as mankind. This is disturbed. That's the spirit of that. That's why I also said 6, 7, 8, 9, 10. It doesn't matter, just change it. So this way I hand over to you.